Hi, as promised, we have another derivative type, but we don't have to learn any new techniques. So 2.6 is called higher order derivatives. Basically, you just keep taking the derivative of a function. So if you have taken one already, you take it twice. We call this the second derivative. Then we have the third derivative, the fourth, etc. This looks really weird. So notation wise, we have three. We put three tick marks. After that, we put the number, the order of the derivative in parentheses. So if you like have the sixth, f to the sixth in parentheses, just because too many tick marks gets a little ridiculous. So that's not a 16. Here we go. You can keep taking the derivative until your function is either no longer differentiable or you get a zero, and then you just take the derivative, it's still zero over and over again. We do have some functions which are infinitely differentiable, but most of the ones we deal with, actually that is two. A lot of the ones we deal with are going to have a natural stopping point. Your polynomials can only go up to one more than the highest degree. If not, you turn into zero. Your 1 over x type functions, those can potentially go on forever. I'm trying to think of a case where they wouldn't. Not because your bottom just gets worse and worse every time, like bigger and bigger, messier. Yep. We don't deal with it in this class, lucky you, but your trig functions, you can differentiate most of those forever. They just kind of cycle back and forth through a couple. All right, let's find some derivatives. So honestly, it's fairly straightforward. All the methods we've used already, we're going to use this. It's nothing new. So we're going to find the first 5 derivatives of this function. It's not going to take as long as it sounds. Oh, apparently we're using black this time. Go us. First derivative, take the derivative of the first thing, which is just 8x cubed minus the second, 6x. That's that. Second derivative. My numbers are going to get kind of gross. 24x squared minus 6. So each time we take a derivative, we lose a degree for all of our terms. F triple prime, I get 48x. 6 drops off because the derivative of a constant is 0. F to the fourth derivative gives me 48. And f fifth derivative is just 0. So honestly, these are pretty straightforward. As derivatives go, you just keep going until they tell you to stop. We're going to find that a couple equations we need, especially in like physics, you'll need multiple derivatives. As we go, the derivatives will tell us different things. We haven't really done graph analysis. I think that's coming. Your second derivative tells you quite a bit. I can't remember if we use the third derivative or not, but sometimes it can tell you more as well. Usually the first two are the main ones we do. Oh, whoops. Oh, man, I was mean on that one. All right, we're going to find the third derivative of our function and plug in 2. So the plug in part is the last thing we do. I'm going to switch colors. All righty, g prime of t. Hopefully I don't lose the t. Negative 4t cubed plus 6t squared plus 1. The 4 goes away because it's a constant. G double prime of t. If I were to plug the 2 in now, I would get g prime of 2, which doesn't tell me what I want. And then if we try to take the derivative of that, it's a constant, so it zeroes off, and we would get a false answer, a wrong answer. Bring this down, I get negative 12t squared plus 6, nope, plus 12t. The 1 is a constant, it leaves. Finally, the triple prime, negative 24t plus 12. And g triple prime up 2, negative 24 times 2, 12, which equals negative 48 plus 12, which is finally negative 36. That's what we were looking for. Again, these are not terrible. We've learned all of the techniques we need. Now it's just applying them, plugging them in. Oh, that was not very nice. Oh, that's the last thing we need. This is a short video, so I don't feel too terrible about this. Okay. I'm going to rewrite this as x to the negative 1. We could use quotient rule on this, but it honestly makes it worse, so let's not. Sorry, my cat is singing the song of his people as he does every morning. First derivative, negative x to the negative 2. So bring the exponent down, subtract 1. Second derivative, hello, kitty cat. I'm sure, yes, everyone wants to hear from you. Come on, hop up. Okay, now I have a cat on my lap. No, don't eat my pen. Sorry. Negative 1 times negative 2 is a positive 2, x cubed. You sit. All right, negative 3 times positive 2 is a negative 6, x to the negative 4. Fourth derivative. I don't think they can hear you purr. Yeah, no, leave it alone. Negative 6 times negative 4 is positive 24. Wow. X to the negative 5. My pen doesn't want to work now. There we go. I blame you, kitty. We could keep going infinitely. I don't want to. Your denominator is going to get bigger and bigger and bigger because it's x to the whatever power. That as x gets bigger, it gets really big. But we could just keep going. All right. Yes, thank you. The last bit of this is our physics functions. So our position is your base function is your f of t. So it tells you where you are, and a lot of times you have like a thing moving back and forth, or sometimes it's a function you're moving different places on there. Your velocity is, we think of velocity as speed. So if we want speed, it is the first derivative absolute value. Velocity is speed with direction. So we can have negative velocity if you're moving away from the point. So if this is our forward direction and our graph moves forward, we're going to have a positive velocity. But if we're going backwards, we'll have a negative velocity. Interesting way to measure it, honestly. And finally, your acceleration. How much is your speed changing, or your velocity really changing at that point? That's your second derivative. Couple problems are going to have you use this. I don't think they make you create the functions, but if they do and you get a little lost with that, come talk to me. We can figure that out. But beyond that, that is it. We have one more section in this chapter, which are our implicit differentiation, and that's using our chain rule again. So we will do that next, and then we'll be done with chapter 2. All right, the cat says bye. He's leaving. No, don't eat my yarn. Okay, bye.